my roll number is IC2K2341 and I am from the course MCA. So today here I am to explain you the topic which is process synchronization. Okay. So let us understand what exactly is process synchronization. It is used when multiple processes are working together and sharing the data. If they access the same data at the same time, it can create errors. So synchronization is helping us in managing the processes properly and to give the correct results. It is actually ensuring data consistency and also proper execution. Okay, so now let us understand about the next topic, which is critical section problem. Okay. So now what is critical section? It is a part of a program where shared data is used. Okay, it can be accessed. For example, when you are updating the bank balance or editing any sort of file, that is the example of critical section. If more than one process enters this section at the same time, it can create a problem which is called race condition. Now what is race condition? It is when the results are depending upon the process which is running first. Okay. So it is working on the race condition. Okay. Now the next is we are going to discuss about the requirements of critical section solution. Okay. So there are three requirements which are mutual exclusion, progress and bounded waiting. Okay. So now what is mutual exclusion? It says that only one process can enter at a time. Okay. The next is progress. It says that no unnecessary delay should happen. Okay. Like the selection of next process should not be delayed. It should be in time. The next is bounded waiting, which says that every process should get a fair chance. Okay. So these requirements are ensuring that every process is getting a fair chance. Okay, fairness among all the processes. So now let us understand what is the relation between mutual exclusion and synchronization. Okay. So mutual exclusion ensures that only one process works in the critical section at a time, and synchronization means processes executes in the correct order. Okay. So mutual exclusion is telling that only one process can run at a time in critical section, and synchronization is saying that the processes should execute in the correct order. So together they help us to avoid data errors, and also it ensures to provide us the correct results. Okay, that's why they are working together for efficiency. Now, one more thing, that how we can implement this. Okay, how we can do that? So there are two main techniques by which we can do it. One is locks and the second is semaphores. Okay, so now locks are used to control access to shared resources. Means before entering the critical section, a process locks it, and after finishing it unlocks it. So there are different types of locks, we can say, like mutex and spin lock. Okay. Other than that, it is like lock means acquire, means process enters. Unlock means process exits, means it is release. So it is ensuring that only one process is working at a time. Now let us understand the different types of locks, which are mutex and spin lock. So mutex says that only one process at a time, and spin lock says process keeps waiting until lock is free. Okay. Now, now let us understand the next technique, which is semaphores. Okay, semaphore is an integer variable which is used for process synchronization. Okay, So what is happening? It is a variable that is controlling that how many processes can access a resource. Okay. So there are two operations. Wait, which decreases the value, and signal, which increases the value. If the value is not available, the process has to wait. Um, okay. Then there are two types, binary semaphore and counting semaphore. Binary semaphore is for mutual exclusion, means only one process at a time. Okay. And counting semaphore for multiple resources. Okay. This variable S tells us that if S is less than 0, then the process will wait, means it will be blocked. And if S is greater than or equal to 0, the process will continue. Okay. So now, after these techniques, we are going to learn about classical IPC problems. Okay. So, there are some standard problems which are used to understand synchronization. Okay. First is the producer-consumer problem. Okay. In which one process produces data and another consumes it. Okay. Now the second problem is dining philosopher's problem. It says that processes compete for resources. Okay. And the third is readers writers problem, in which some processes read data and others write data. So this is happening when processes uh, are like some problems are created. Okay. Now, these processes help us to understand real life situations properly. Okay, in a better way, we can say. Now, the next is deadlock and characterization. So, deadlock is a very important term. Deadlock specifies that it is a situation when all the processes are permanently blocked. Okay. Each process is waiting for resources held by another. Okay. So, it is like this is happening when processes are waiting for each other, and there are four main conditions on which the deadlock, when the deadlock happens. Mutual exclusion. It is resources used by only one process at a time. Hold and wait. Process holds one resource and waits for another. No preemption. Means resources cannot be taken forcefully. Okay. Then circular wait. Processes are waiting in a circular chain. If all these happen together, if all these four conditions happen together, deadlock will occur, which means all the processes will be permanently blocked. Okay. So now we are going to discuss about the methods of handling the deadlocks, means how we can handle that. So first is, we can say prevention, where we are avoiding one condition. Okay, eliminating one of the four conditions, that is prevention. Now second is avoidance, where we are keeping the system in a safe state. Okay. Third is detection, where we are finding deadlocks after they happen. Okay. We are trying to detect that where the deadlocks are there. Okay. And the last one is recovery, means where we solve it by stopping processes or releasing the resources. Okay, so these were the methods of handling the deadlocks. So here our topic ends, and here I will just give you a summary for all the topics which I have explained you today about process synchronization. So process synchronization is very important for correct, you can say, execution and also data consistency. Okay, it is processing to work correctly and avoiding errors, like you can say race condition. Means output will not depend on the process which is running first. Okay. Now locks and semaphores are helping us to control the access to shared resources. Means which resources will be used by which process. Okay. And deadlocks can occur if resources are not managed properly. And there were four conditions we talked about. If all those four conditions occur, deadlock will be there. Okay, so handling them is very important. For that also we have discussed some methods. Okay, so preventing race condition and data inconsistency, all this is coming under the topic of process synchronization. Okay, so I hope that you have understood this topic. Thank you so much for listening me properly.